So yeah, as you said, my name's Tyler Akidau. I'm the CTO for Redpanda Data, and I'm really happy to be here. And so today I'm here to talk about Agentic AI and kind of the intersection of that with streaming. And like I said, I'm coming to you from Redpanda. In case you don't know who we are, I'll give you a little bit of context real quick. We are a streaming platform that powers mission critical, real time, low latency, high throughput workloads the world over. Uh, Sort of more architecturally speaking, we're really at the core kind of three main products. We're a connector suite that provides input and output connectivity from a broad suite of data sources and sinks, 300 and more. We are the world's fastest and most scalable and frankly most badass Kafka implementation out there. I think, as Felipe said last time, we're built on C Star in the same vein as Scylla, and it's just a sweet system. It's really, really well built. And then we are the Redpanda console, which is it is a UX for observing and interacting with your Kafka workloads, and it's used by an insane amount of Kafka users the world over, not just Redpanda, because it's so damn useful. So that's kind of the core products that we have today. One of the things that we see as really valuable going forward is kind of the agentic AI market and how we can kind of bring value there. And so, talking about myself, as they said in the intro, I've had the fortune of writing a bunch of things and working on streaming. I point out here kind of my background. Main reason being, I want you to understand where I'm coming from. Like, I'm not really an AI person. I did use ChatGPT to make that image, so that's something. But I do know a lot about streaming, and so as we've been kind of learning about AI and thinking it through, there's been a lot of stuff popping into my head of like, there's just dozens and dozens of AI startups out there, right? And they're all kind of trying to solve these problems. And I'm sitting here thinking like, it really feels a lot like a streaming problem that we like solved or thought we solved 10 years ago, and the database community probably solved it 30 years ago. But like, it's just sort of been kind of mulling over in my head. And so that's kind of where this talk came from, was I just saw a bunch of patterns where I was like, feels like streaming is actually the right way to solve this. Maybe it's worth kind of talking about. And so that's where we're going to go. So there's going to be kind of four main sections. I'm going to briefly cover what is agentic AI, or at least what do I think agentic AI is. I'm going to talk again briefly through the opportunity of agentic AI, why I think this is important, why am I spending the time talking about it. And then I'll dive into at least some of the challenges that I've seen and we've encountered with trying to deploy agentic AI, principally in enterprise situations. And then I'll kind of walk through my list of things that I feel like if you kind of approach it through the streaming lens, can be helpful. So let's start out with what is agentic AI. If you haven't read it, I really like this Anthropic article around building effective agents. They're kind of very precise in how they define it. They basically, they kind of want to categorize it as two different types of agentic systems. There's workflows where you've got human written code that kind of gives a very structured orchestration of what a given agent should do, and it's probably making very focused calls out to LLMs. And then there's this thing that they define as agents, which they basically say it's an LLM and you've given it a task and it goes and maybe it does that task, maybe it doesn't. Both to them are agentic systems. But the article is really well worth a read. It gives a lot of good context and framing. For myself, I'm of the opinion that an agent is an artificial intelligence, which today basically means an LLM, performing work. I don't care if it's part of a workflow or if it's fully autonomous. I'm going to call it an agent either way. So if you hear me say agent, that's what I mean, because I'm not picky. To kind of draw it out a little bit, and again, I'm sure if any of you have done any stuff with agents, this is nothing new, but it's useful to have pictures. Basically, an agent is an LLM, or it's a workflow built on LLMs. It gets some inputs. It interacts with some tools. Often, the MCP protocol that's kind of hot right now is one of the ways, but there's plenty of other ways you can plug tools into these agents. And it produces some outputs. And so as soon as you see this diagram, it should start to kind of click for you that this looks awfully like a streaming sort of a thing. Like, it's kind of like a function that you're shoving stuff into and stuff comes out the other side. But that's enough, and that's all I'm going to go into as far as what is an agent. This is enough basics for that. So what's the opportunity? Why does this matter? Well, AI has already, I think, materially changed the way that we lived. Besides me being able to create, cool little images of wallets with, a few lines of text, it's just materially improved our ability to reason about the rest of the world, learn about the rest of the world, have essentially a co-pilot. I know that term's used a lot, but really a co-pilot that helps guide us and sort of coach us through complex tasks that otherwise, you needed to have a friend or an acquaintance or someone you've paid who was deep, had deep knowledge in an area. Now we can kind of all just have that friend sitting in our pocket all the time. It's huge. And I think if you kind of look at the way things are heading, like every business interaction is likely to be mediated in some way by AI in the not so near future. Like maybe it's 2 years, maybe it's 4 years, but it's probably not that far out. I think it's probably not a question of if at this point. It's when, and it's how, and it's who. But that gets into the next section, which is the challenges. If you look at the consumer AI market, like it's just flooded and it's largely successful. Like there's huge penetration into the market. Lots of people are using it. But the enterprise agentic AI market is not doing great. Like there's a bunch of articles on this. I linked a Gartner one, I think. Enterprises are really struggling to have it take hold. And it's really boils down to running agentic systems safely in your private network on private data is still really hard. And there's a bunch of reasons for that. I'm going to kind of cover a list of them that I think is more useful than focusing on just one. But I do like to start out with this one framing that I think really helps kind of put it in its place. So do any of you play Dungeons and Dragons? Or at least, are you familiar with Dungeons and Dragons? Come on, this is a tech conference. There's got to be more than one. Are you kidding me? You are killing me. Okay. Like literally, I used these slides last week at our sales kickoff, and I had more people raising their hands than here. I am shocked. Anyway, Dungeons and Dragons has this thing called an alignment chart. It's used to kind of help frame the personalities and the behavior traits of a character in the game. And it goes like from left to right. Yeah, left to right. It's lawful on the left, chaotic on the right. So lawful is like I like to follow rules. I try to do the right thing. Chaotic is YOLO, like I'm going to do whatever I want. It doesn't matter. And from top to bottom, it's good down to evil, right? And good is basically selfless, and evil is basically selfish. And so if you think about agents and AI, like what are they doing? Well, in essence, like they're these really smart beings that kind of can function like a human that's literally plugged into the computers. And so there's sort of like these new agents that are entering the workforce. If you think about how we've hired humans forever, we've got these long filtering processes of like, we look at your resume, what school did you go to? We get references, we do interviews. Like it's so much work goes into being like, do we want to hire this person? It's basically what that's trying to do is pick the people that are largely up in lawful good. Realistically, we kind of hit the upper left quadrant. And if you look at like, I think a lot of tech companies, like when I was at Google for a bunch of time, like there's a bunch of chaotic good folks at Google. Like, they're tolerable, but like we really kind of try to keep everyone up there. But if you think about agentic AI and what you're deploying into your private networks, AI today is basically hanging out in that chaotic column. And all the guardrails and all the kind of training that they put into it, they're trying to push it. I mean, really, they're trying to push it up into lawful good, but like the best we get is chaotic good, I would say at this point. And so this is what you're contending with, is you're like, okay, well, let's go just shove all these things in our private network on our private data with access to the internet. What could go wrong? This is why agentic is struggling. But really, if you want to deploy it safely and effectively, there's a whole list of things that you need. You need context building and maintenance, right? Like LLMs are trained on this vast data sets, but like in any sort of business use case, they generally need some specific business context information, whether it's specific data about your customers or whatever the interaction is, or just like docs that they weren't trained on because the training takes so long and it's like a year old and out of date. Like you need to provide them with extra content. And that content also needs to be maintained over time if it's a living, breathing data set, which most useful data sets are. Most useful data sets are dynamic. You need context querying. You need ways to retrieve that data. You need auth. Like I said, you got to make sure that agents can access the right data. They can't access the wrong data. They can do the right actions. They can't do things they aren't supposed to do. You need governance, kind of controlling all this stuff. Making sure that like PII is enforced effectively and things like that. You need auditing. I'll kind of go into more of this, but you've got to know what these things are doing. You need some way to validate that they're actually, as you're kind of building and deploying them, you need to be able to do, sort of replay data through agents and figure out, are they actually doing the right thing? Is this effective? You need routing. I'll kind of go into an example there, but there's a lot of cases you need to send data, specific portions of data or filtered subsets of data around. Like there's a lot of data movement that is required to build effective agents. And if you're building complex agent systems with multiple agents, you've got to coordinate them somehow. And I mean, this is probably not an exhaustive list. This is kind of the thing I came up with off the top of my head, but this starts to feel pretty solid as sort of the things that you need to build agents. And like most of them are really data streaming problems. This was the thing that kind of struck me looking at it. And so what we're going to do today now in the remaining of the time is just kind of walk through each of those data streaming problems and say, well, look, this is how streaming can help. So the first one, context building and maintenance. I mean, this one should be obvious. Like this is just classic streaming ETL, right? Like you want to build up context, sort of data sets that are useful for these agents, whether it be building knowledge bases and shoving them into a vector database like Pinecone or something, or you're just doing CDC from a database and dumping data into an OLAP database because you need to be able to do analytical queries. Like this is a well understood and well-trod sort of streaming use case. But it is critically important. And I think the more that you can, what we've found with agents is the more you can keep your context and data up to date, the more effective the agents are, right? And so streaming becomes ever more important because if you want agents who don't really have context and aren't as good at kind of reasoning about, well, this is a data set that's like a day out of date, so I need to keep that in mind when I'm looking at it. Like you really want to keep your data up to date. The next one is governance. And governance can mean a lot of things. And it really doesn't need to be a streaming problem. But the idea with governance is you're wanting to say, look, I want to define, like I got a bunch of data sets. Again, we got some vector databases, we got a bunch of SAS tools, maybe we got stuff shoved in some OLTP or OLAP databases, we got Kafka streams, things like that. Who can access what data? Who's allowed to write to it? Who's allowed to read to it? Who can drop the databases? These sorts of things. Like all of this ultimately gets configured in some way in these source systems. But when you're looking at building agentic systems that span across these and wanting to enforce consistent behaviors within those agents, where do you configure that? How do you ensure that agents are doing the right things and only the right things? You can enforce this in all of the individual data sources if you want, but in a large enterprise with all this technological sprawl, like it's a pain. Like there's so many different places and you got to try to keep it consistent. And so really when you think about the way, what streaming, one of the things streaming really brings to the table is this data movement, this interconnection of data. And when you're trying to interconnect a broad set of data sources across the enterprise to this broad fleet of agents, the right way to enforce governance for those agents is within the streams because the interconnection is touching everything. It's touching all the data sources, it's touching all the agents. If you have a system that allows you to configure, agent X is allowed this type of data accesses and these types of rights and things like that, and it just sort of gets applied anytime that data shows up in their path with those credentials, that's way easier than the former where you're trying to replicate these sorts of roles and things and access controls across a bunch of different silos. The next one is auditing. Auditing is a huge one. So if you go back to thinking about the alignment chart, like you've got these chaotic agents you're putting out there, but what's worse is like you can't introspect like what's going on in there. Like you can't pick apart their brain. You can't say, well, what is where's the for loop going, and what's the switch statement? Well, like you can't introspect it. Like it's basically a black box. And so the only thing you can really do when you're wanting to say, well, what is a given agent doing, and or what is it doing in response to given inputs, is you got to record all the inputs, you got to record all the interactions with tools, and you got to record all the outputs. It's like historically we've kind of for auditing purposes, we've logged typically metadata requests, or like user X read, these many bytes here, but we don't usually record the bytes because it's gonna be a lot of data. But when you're dealing with agents, you got to record the bytes, because you got to be able to go back and see like, okay, it got this request, it then went and pulled, this data from our SQL database and this data from the knowledge base, and then it decided to go and drop all the databases in the metadata table. Like, you can't make those inferences without having the whole data set there and being able to say like, okay, we see what happened. Better luck next time. And so again, this is where streaming really comes into the picture of like, we've got these streaming systems that are really good at like high throughput, low latency, just append a bunch of data as it comes along, durable log. You need a bunch of durable logs that scale really well. Streaming's a really nice fit here, and it makes your life a lot easier when you're trying to reason about how these systems behave. The durable log also plays into replay and validation. So when you're developing, you want to be able to say, okay, does this thing even work? Well, if you can define, your input data set, synthetic, based off of real production data, whatever, you can then say, all right, I'm going to plug this version of the agent that we built into it, plug in all the tools and pump it back through, see what happens. Allows you to do this during development. Again, you can do kind of the time travel debugging when you're auditing in the background. It's a really useful tool for being able to reason about behaviors of these very complex systems that you otherwise can't introspect. Next up, dynamic routing. So this one's a streaming problem only in the sense that like streaming often has these sorts of pipeline topologies. Like you don't need a streaming system necessarily to do this. You can just do this with like Envoy or direct connections if you want. Although there is something nice about the decoupling of a system like Redpanda or Kafka. But I think the important thing to just keep in mind is like LLMs are not the be-all end-all tool, right? Like they're frankly quite expensive. They require a lot of compute. They're not super fast. You're not going to shove 1 million records a second through an LLM. I mean, you can if you have a lot of money and a lot of GPUs, but like you're probably not. And so I think what we're seeing people do with things like fraud detection is historically, kind of the state of the art has typically been ML models, with ML or some combination of heuristics. You still probably want to keep those systems around, but then you want to be, if those systems say, hey, something's fishy here, and maybe you can dial them down a little bit, maybe you can allow them to be a little more inclined to say something might be fishy, then you hand whatever the sketchy stuff is off to an LLM, a fraud detection agent that's been sort of trained to be more capable of detecting these sorts of things, give you better results on those, we're not quite sure sorts of things. But the vast majority, assuming most of your traffic is typically not fraud, like you just keep shoving all the stuff that isn't fraud just right into the right path. The ML model is way cheaper to run. Heuristics are way cheaper to run. Just spend the extra money and time on the cases where you really need that help, that intelligence, and that ability to kind of think things through more deeply. And so again, being able to do this, if you're building on a streaming architecture, you kind of get this ability to route like this for free. You don't have to do it with streaming, but it's a very streaming sort of thing to do. And then the last one, multi-agent coordination. I mean, this one, again, kind of just feels like a classic streaming use case. If you think of the kind of the microservices architecture sort of the thing where you want, what do you want in microservices? Well, it's really nice to decouple them. So if you've got one that's slow or not working well, it doesn't hold everybody else up. It's nice to have the durability because machines crash or whatever, and having durability gives you the chance to wait for machines to come back up and pick off where you left off. It's nice to have fan in and fan out, and not have to have a producer. I mean, three agents to write to isn't horrible, but as the number increases, it's a load on a producer to be like, all right, I got to produce to like 20 different things. If you can just produce to one durable log, and then consumers on the other side can consume at their leisure, it's a much nicer approach. And so having this sort of streaming durable log here within the topology of your multi-agent system, again, just makes the whole thing kind of easier to maintain, more durable, more reliable. And that's really all I wanted to talk about today, was just kind of, me musing as a newbie to the AI space of like, gosh, it sure looks like there's a lot of streaming problems in there. It's not everything, obviously. Like, you need auth-in, you need auth-c. That doesn't really have anything to do with streaming. You probably need a multimodal catalog for the context data. It's not just all streaming data, but that's fine. You need querying. Querying isn't really a streaming problem. I mean, there's a lot of similarities in the data processing space for sure, but if you're building workflows, you probably need durable execution for them. Things like DBoss, Resonate, Temporal. Really nice systems for that. There's other ways to do it too. Yeah. But that being said, I think what's been interesting to me is I didn't expect coming into it that I would see streaming be such a foundational piece of this kind of agentic data plane. And so that's all I wanted to share today. That was kind of my observations, and I thought it was interesting. Thank you for attending.
Okay, thank you for the talk. So you mentioned in the last topic is multi-agent and useless streaming. And we also see some database has a branch functionalities. So can create a branch in maybe 1 second, very cheap. So what's your opinion for the difference with using the database branch compared with the streaming for multi-agent?
So a database branch is like a snapshot?
Do you know, for example, the neon? For example, the snapshot is very time consuming, and the branch can be very fast because they share the objects.
It's like a copy on write, basically?
Yeah, copy on write, yes.
That makes sense. I guess my take would be you should use the right tool for the right job. If that fits into your workflow, that's awesome. There's many ways to skin a cat. There's different ways to do this. I think copy on write mechanisms are fantastic. Like if you need state and you want to be able to basically fork your state cheaply, a copy on write branch sounds very useful. I think I'm not immediately seeing how that is a replacement for the types of things you get from durable streams interconnecting multiple agents. But I'd sort of be curious to learn more if we want to spend time afterwards. Anyone else?
First, thank you for very great presentations. And my question is regarding make the data available for all the agents, and especially in LLM, there is a challenge on those latency, especially tail latency. And when we start moving to the agency, and especially in the distribute environment, this problem could be aggregate. Do you have any insight regarding how to reduce latency, tail latency, this kind of challenge?
I mean, you could use Redpanda. I think it's a good question. Like, I think one of the interesting things about agentic is it is moving more and more towards machine-to-machine interaction. And in that case, you really do want these systems that are really low latency. And I think that is why we see Redpanda as being a really key part of building out this infrastructure going forward, because you're gonna want durability, but like you said, you're gonna want these really low tail latencies, because you're already churning a bunch of time on the LLM doing its thing. You don't want to burn more time on your infrastructure, especially as it compounds of like layers and layers of transmission and all that. So yeah, I think building efficient systems and aiming to keep latency low is a good pattern. And the other thing in the interim, while LLMs will just get faster and machines will get more powerful, but in the interim, being judicious about the application of them is kind of the other path we have to go. Like the routing page I said of pick the right tool for the job. And right now LLMs aren't always the right tool, but they're going to be more and more the right tool.
Great. I will follow up with you. Yeah.
Sounds good. Thank you.